So this one says, for 3.9, solve each equation by undoing the operations that have been done to the variable. So for part A, I have t squared equals 400. So how can I solve for t?
What, the square root of 400?
Yeah, so we just square root on both sides, right? So we just get t on the left. And what do we get on the right?
20.
So this is one special thing. Whenever you have some value squared, right? So in this case, we have t squared. We have two different solutions, okay? And what I mean by that is we can plug in two values for t. That'll result in a true statement, right? So we could do positive 20. So 20 squared is 400. But we could also do negative 20, right? So negative 20 times negative 20 is a positive 400. So the way we can write this is we can say t is plus or minus 20, right? So we can have a positive or a negative 20, and they're both solutions to this equation. Okay? And a way that you can kind of remember that it's a positive or negative 20 is whenever you have an even power. So like if you have it squared to the fourth power, to the sixth power, and so on, and you put in your own square root. So like in this case, we put in our own square root. You know that you're going to have a positive or negative answer. So that's just kind of one of the things that you just kind of have to get an intuition for. Is whenever you have an even exponent, you're always going to have a positive or negative answer. Okay. Okay. So for part B, how can I start solving for t?
Divide 4 on each side.
Yep, divide by 4 on each side, right? So we get t squared on the left, and we get 100 on the right. Yep. Okay. And now what can I do?
Take the square root on each side.
Yep. Take the square root on both sides. So we get t on the left, and what do we get on the right?
Plus or minus 10.
Yep, plus or minus 10. Right. Okay. What about c? How can I solve for y on c? So notice on a and b we did the inverse of it, right? So if we had something squared, we square rooted it. So the inverse of square rooting is just squaring. So what I can do is just square both sides. So the square and the square root cancel, so I just end up with y. And 9 squared is 81. So y equals 81. And notice that it's not going to be a negative 81 in here if we plug in for y, because you can't square root a negative number, right? We're just looking at positives. Okay, and we can do the same thing for d. We can square both sides. So we get 3y equals 81. Okay, and then we can just divide by 3 on both sides. So divided by 3 on both sides, 81 divided by 3 should be 27. So y equals 27. Okay. All right, letter E. So we have 1 over x equals 8. So does anybody know how I can start solving for E, for letter E? What if I do 8 over 1 instead? What can I do now? Well, hopefully you remember this, but I can cross multiply, right? So I can do 8 times x, which is 8x, and it equals 1 times 1, which is 1, right? And then just divide by 8 on both sides. So I get x equals 1 over 8. Okay. Okay, and then similarly, I can do something over here where I cross multiply. Right. I get 16x. 16x equals 1 times 1, which is 1. Divide by 16 on both sides. We get x equals 1 over 16. Okay. All right, any questions on the first 6? Okay, so I'm going to introduce you to something called a quadratic equation now. So a quadratic equation, we have it written in this form, ax squared plus bx plus c equals 0. Okay. So this ax squared, the reason it's a quadratic is because we have that squared right here for our variable. Okay. So as long as the biggest term is an x squared, it is a quadratic equation. So an example that they have, 3x squared minus 2x or equals negative 2x minus 5 is a quadratic. Since we can basically change everything to the left side, so we have 3x squared plus 2x plus 5 equals 0, right? So the way they did that is just add 2x on both sides and then add 5 on both sides. So we get 0 on the right and we get everything else on the left. Okay. Okay. So in 2.15, we learned the Pythagorean triple is just a set of 3 whole numbers that satisfy the Pythagorean theorem. So it says complete this Pythagorean triple. So we have 8, some number, and 17. So we have some leg that we don't know the answer to. And does anybody know what that is off the top of their head? I don't know if we covered it or not, this specific one. Hopefully, so nobody remembers it, so that's a good thing then. So, and the reason that's good is we can just solve for b squared, right? So we have one leg plus another leg squared equals the hypotenuse squared. So how can I start solving for b here in this equation? So how can I solve for b here?
Oh,
Square root both sides.
So we could, right? But if I do that, if I have something plus another thing when I'm square rooting, I'm not going to get a very nice answer, right? Because I can't just take the square root of the first one and the square root of the second one. So I want to start isolating b first, and then I'll square root both sides. Right? So how can I start isolating b?
well, you want to first find out what 64 plus 289 is.
Yeah, and how did you get those two numbers?
I did 8 squared plus, and then I did 17 squared.
Yep, so let's square those two numbers that we know the values of. So 8 squared is 64, plus b squared is equal to, and 17 squared is 289. Yep. Okay. So what can I do now?
Now you got to subtract 64 from 289.
Yep, subtract 64 on both sides. So we get b squared equals 289 minus 64, which is 225. Right? And then now I can square root, right? Because I just have b on one side and a number on another. So we'll square root both sides. So we get b equals the square root of 225, which is 15. Right? So my question is, why didn't I put a plus or negative 15 here? Because I inserted my own square root, right?
Because it's the Pythagorean triple, so it's
Yeah, so can we have negative distances?
no.
No, right? You can't have a negative distance. So the reason that it's a positive 15 is because we're talking about the distance of a triangle, right? And you can't have a negative distance on a triangle. So in this case, we only look at the positive 15 case. Okay. Okay. Move on to the next page then. So this one says solve each equation. So we're going to do a little bit more solving here. So we have a square root equation on the first one. So what I'm going to do is the opposite operation that's being done to x. So in this case, it's square rooting. So we're going to square instead. So I'm going to square both sides. Okay. So the square root cancels out. We get x plus 8 on the left. And on the right, we get 64 squared. So I'm going to leave it at 64 squared because I know it's going to be a really big number. And then now just to solve for x, we can subtract 8 on both sides. So x equals 64 squared minus 8. Right? And if you wanted to, you could do 64 squared in your calculator. But I'm going to omit that on part A. Okay. Okay, so a quadratic equation. So how can I start solving for x here in part B? Anybody know?
Subtract 8 from both sides.
Yep, so we get x squared equals 121, right? If we subtract 8 on both sides. And then after that, we can just square root both sides, right? So I just get x on the
11.
left. Yep. And it's a positive or negative 11, right? Because we're not talking about specifically distances like with triangles. So we would have to include the negative case as well. Okay. And then part C, a cubic equation. So we're still doing the same thing. We're still going to solve for x here. So what I'm going to do is I'm going to multiply by 2 on both sides. Right? So then on the left side, we get x to the third minus 1 equals, and 62 times 2 should be 124. Yeah, 124. And then now we can just add 1 on both sides. So we get x to the third equals 125. And then we can just take the third root on both sides. So we get x equals, and 125, the cube root of that should be 5, I believe. Yep, so x equals 5. Yeah. And since it's not an even power, so it's not 2, 4, 6, 8, so on, we don't include the negative, right? Because if we had a negative 5, if we multiply that by itself 3 times, we get a negative 125. Okay. The next one says, the following equation gives time t needed to travel 300 miles based on speed r. So it says this is an example of a rational function with a variable in the denominator. So it says what speed is required for a 300-mile drive to take 4 hours. So all we're doing is just plugging in variables, numbers for variables, right? So in this question, I'm going to rewrite what they had up here. So 300 over r. So with this question, do we know t or do we know r with the information that they've given us?
T.
Yeah, we know t, right? How much time did it take them to drive 300 miles?
4 hours.
Yep, so I'm going to plug in 4 for t. That's equal to 300 over r, right? So how can I start solving for r here? Does anybody have any ideas? So I could do cross multiplication again, right? But what if I did this instead? What if I just multiplied by r on both sides? So then the r's on this side will cancel, right? And I end up with 4r on the left. So 4 times r or 4r. And that equals 300. Right? And now I can just solve for r by dividing both sides by 4. So we get r equals 300 over 4, which is 75. So what we're saying is that it took them 75, we'll say miles per hour. I don't think it gives it. But it took them 75, or their rate rather is 75 miles per hour, right? So they're just going down on a highway at a consistent 75 miles an hour. Okay. Okay, questions on this one or on this page? Okay. All right, so let's see. This one says solve the rational equation. So we have 64 over x plus 8 equals 1. So to solve this, I'm going to do something very similar to what I did on the last one. What I'm going to do is I'm going to multiply both sides by x plus 8. Right? So the x plus 8's cancel on this side, so I end up with 64. And on the right side, I distribute 1 to x and plus 8. So we just get x plus 8 on the right. And then I can just subtract 8 on both sides to solve for x. So we get x is equal to let's see, 56. Okay. Okay. So what if we're given something like this? It says consider the quadratic equation. It says try solving the quadratic equation by isolating x, and what do you notice? Okay. So if I look at this equation, I have a problem already, right? I have an x here and an x here. And there's not really any easy way to isolate x's, right? Because if I isolate one on one side, I still have an x on the other, right? And you can't really combine those either, since you have an x squared and an x. So what we can do, and I think this will say, oh, by the way, what do you notice? You can't isolate it. So what we can try to do instead is on the next page, all we do is just plug in values for that equation, right? So we plug in 4 for x, we plug in negative 3.8 for x, and we plug in a bunch of values for x, right? So when I plug in 4 for x, I just plug in 4 in each of those, and it looks like I end up with 4, right? So when I plug in a negative 3.8, sorry, that should be a negative 4. When I plug in a negative 3.8, we get a positive 2.84. When I plug in a negative 3.6, I get a positive 1.6. Okay. So what we're going to do is we're going to use this chart to estimate values for x, and we're going to plug in, and then we're going to look at the table, or the graph rather, sorry, and we're going to use that to estimate solutions as well. Okay. So if we look at the table, where do we have solutions for x? So basically what I'm saying is we have this equation x squared plus 2x minus 4 equals 0. So my solutions to this equation is when this left side here is equal to 0, right? So when do I see something on this line and this line equal something really close to 0? So when do we see it almost equals 0 here?
Negative 2.3 and positive 1.2.
Positive 1.2. Okay, so I agree with, wait, what was your first one again? I'm sorry.
Negative 3.2.
Yeah, so we see that it crosses at about these points, right? So between negative 3.4 and negative 3.2, it goes from negative to positive, right? So it has to cross a 0 there, right? So my first solution, or my first guess at a solution is negative 3.3. And then I also see over here, it goes from negative to a positive, so I know it crosses 0 there. So I'm going to guess at 1.3 as well, right? So I see that it goes from a negative to a positive and a positive to a negative, right? So I know that it crosses 0 at those 2 points. And if we look at our graph, if we look at our graph up here, what do you notice about this point right here and this point right here? Where are those located at? So what are my x values at those 2 points?
1.3 and negative 3.3.
Yep, the exact same ones that we found on the table, right? So what I can say to compare these is they are the same, right? So my zeros on the graph correspond to the zeros in my table, right? And that makes sense. When I plug in my value for x, I get a 0 value, right? So if I look at these values here, like if I look at negative 4 for x, we get 4 up here, right? So if I plug in negative 4 for x, I get a value of 4 out of the function. If I plug in 0 for x, I get negative 4. So I plug in 0 for x, I see that I get negative 4 right there.